Now this is the second video. I'm going to continue where I stopped in the first one. So what we're going to do over here is that we're going to continue finding the equation of the inverse. So remember, this is an exponential, so you expect this or the inverse of this to be a logarithm. So first of all, you switch x and y. You isolate the y, or the one with the exponential, so it will be x plus 1 equals to 4 to the power y. Then, after you do that, you have to change this to log. So log of the base, which is 4, and then the argument is x plus 1 is equal to the exponent, which is y, and that would be your inverse equation. Now, I think it would be helpful for you if I do the inverse for the second one, so I'm going to do that. So what's the equation? So the equation is, for the second one, it's going to be y equals to log base 5 of x plus 1. Now to change this to inverse, first of all you have to switch the x and the y. Then you need to change it to exponential, so it's going to be the base to the power x is equal to the argument, which is y plus 1. But remember, we need y, so you need to isolate y, so it's going to be 5 to the power x minus 1 is equal to y, and that's going to be the equation of the inverse. Now, I hope this is helpful. And I think I want to do also the, let me finish part 2 because some of you have trouble with the end behavior. Now, since you know that the vertical asymptote is -1, so then you know that the domain is going to be from -1 to infinity, and the range is always all real numbers. Now, so this is wrong, as x tends to -1, y tends to -infinity. And as x tends to infinity, y tends to infinity. So this is how you do the end behavior. Now let's move on to the third page in our review. Now this is basically word problems. So let's read number 14. Suppose you deposit $500, so that's my initial amount, in an account paying 4% annual interest compounded continuously. Every time they say compounded continuously, this is the equation you use. Find the balance after 5 years, round to the nearest cent. So let's see what each one of those stand for. A is going to be the final amount. P is going to be the principal or the initial amount. E is just a number like 2.7. You can find it in your calculator. R is the rate. You should change it from percent to decimal. And T is the time. So let's plug it in. 500 is going to be your initial amount. The rate, change it to a decimal, so 0.04. And the time, they said it's 5 years, and that would be your final amount. Now, you can plug this in your calculator. Remember, to get to the E, you press second and ln, which is the ln, or the natural log, and you will find that the final answer is going to be 610, I think, $0.70. So that's going to be your final answer. Now let's move on to 15. The Smith family bought a house for this much. If the value increases at an annual rate of 4.5%, how many years will it take for the house to be worth this much? This is the final, this is initial, this is percent. They're asking how many, so they want the T. Now, since they said it's increasing, so this is going to be the equation you're going to be using. So the final amount, it's 117,800 equals to the initial amount, which is 95,000, 1 plus the interest. So you have to change this into a decimal. Some of you will tell me it is decimal, but it's 4.5%, which means 4.5 over 100. It means you need to move the decimal to the left twice. So 0.045 to the power T or X, and this is what you need. Now, my academic, you can plug this in Y1 and all of this in Y2. Then you have to fix your window. So the Y maximum has to be higher than 117,800, so you can put it at 120,000. You may need to fix the X maximum, so graph it. See if the two graphs intersect. If they don't, then you need to see or to fix the X maximum. Move it like from 10 to 20 or maybe to 50 200. So take it slowly. Don't put it as 120,000. So the y maximum has to be higher than this number, but the x maximum can be a 50, for example. Then you go to second trace, number 5, which is intersect. You press 3 times until you get the intersection, and that would be your answer. My pre-AP, guys, you have to actually show me the work and let the calculator step B to the end. So first of all, you need to divide by 95,000, which is going to be 1.24 over here, equals to 1.045x, or t. Now remember, to solve an exponential, you have to change it to a log. So basically, x is going to be equal to log of the base, which is 1.045, and the log of 1.24. Now you plug this in your calculator. You can go to math and then log base and enter it as it is, or you can change the base. So you can do log of 1.24 over log of 1.045, and the final answer is going to be 4.887 years, which is almost 5 years. Okay, so let's move on to number 16. You bought the Xbox 360 game system for $300, so that's your initial. The value of the system decreases by this much rate. How many years will the system be worth only $50? And that's the final amount. Since they said decreases, so this is the equation you're going to be using. So the final amount is equal to the initial amount, 1 minus the rate. So you need to change the rate from a percent to a decimal. So it's going to be 0.255. And they said how many? So the t is going to be your x. Again, academic, y1. All of this is y2. Change your window, so y2 would be more than a 50. Start with that. The y maximum. Graph it. If you can see it, great. You have to see the line. If you cannot see it, maybe increase y maximum by a little bit. And then x maximum, you might need to increase it to a 50 until you see basically the intersection, and then you follow the same steps. My pre-AP, you have to show me the work and keep the calculator to the end. So 50 divided by 300 is going to be 1 over 6 is equal to 1 minus 0.255, which is 0.745 to the power t. Now this is exponential, change it to log. So t is going to be equal to the log of the base, and then 1 over 6. You do this on the calculator like we discussed earlier, and you're going to see that the time is almost going to be 6 years. Now let's move on to number 17. Now you have this much radioactive isotope with a half-life of 23 minutes, so that's going to be your K. That's going to be your K. How many milligrams will be after 1 hour 15 minutes? So that's your time. Remember that the time and the K should be of the same unit. So if this is in minutes, you have to change all of this to minutes. So 1 hour is 60 minutes, and 15 minutes, that's going to be 75 minutes. Now, so you start, and they want to know how much will be left. So where were we? Okay, so they want the final amount that's going to be left over. So the initial is going to be 120 and half. So every time, remember, if they say half-life, it means you use the base as half. If they say double, you use the base as 2. Or if they say triple, you would put 3. Always to the power t over k. So that's your equation, okay? So the t in this case is going to be 75 over the time, or over k, t over k, which is 23. Now you plug this in your calculator, and you're going to find that the final answer is going to be 12.519 milligrams. So that's the final answer. Now let's move on to number 18. In number 18, they're telling you that the number of bacteria N is found to double in size every minute, and if the number of bacteria is given by this equation, so basically this is the equation you need to use. N equals to 2 to the power x. How many minutes must pass before there are more than 200? Okay, so this is the equation you need to use. So basically, it's a word problem that will end up to be like just an inequality. Now remember, guys, when you want to solve something like this, there are two ways to solve it, so I'm going to use both methods. Some of you, so 2 to the power x, they said more than 200. So the first method says that you need to change this into a log. So x is greater than log base 2 of the argument. So x is greater than log of 200 base 2. So x has to be greater than 7.64 minutes. So you can say that x can be greater than 8 minutes. So this is the first method to solve. Another method to solve, because some of you hate to change from exponential to log, or you find it hard, what you can do is you can look at the base. The base is 2. It means you use log base 2 and log base 2 and put it in front of each one of them. Log base 2 of 2 will cancel out. You are left with x greater than log base 2 of 200. So you're going to end up with the same way. So if you find it hard to change from exponential to logarithm, you can look at the base and use that type of log in front of both of them, and it's going to give you the same answer. So I hope this was helpful, and this is the end of the second video. There will be a third video to discuss the last page.